Welcome back, students. It's Mr. Campbell here with our Friday video lesson. And as you guys can see here, again, you had the vocab due today. I did grade some. I did grade maybe some articles. I had some students turning in some work. Oh, we also had the notebook check, right? That was pages 3 and 4. Page 3 was the diagram of the layers, and page 4 was the kind of the summary of all the different layers, like what they're made of, all the elements in them, you know, the density, the state of matter, all of that, right? So again, I had, I think, like of 31 students, I'm going to say maybe 6 or 7 students turned that in today. Now, I'm not going to get too, on it, because I will say it's not due till Tuesday, like the full, like, turn in last day for full credits Tuesday. So you guys have time. Make sure you get that turned in before Tuesday. Make sure you get assignments in as soon as you can, because I see too many students maybe with some missing assignments, and that is not good for our grades. So we've only got like 2 or 3 weeks left of the quarter till it ends. So make sure you guys take advantage of those assignments, get those turned in, get as many points as possible for your grade. Okay, so let's go and get started, guys. We've got to discuss some magnetic field stuff today, starting off with our Go Blue. And then, yeah, the quiz is going to be posted later. Hopefully, it's going to be Friday night or Saturday, early Saturday. Again, I'll just push back the due date for that a day later. It's like Wednesday. So we'll get that done. Do your best on it once your notebook and everything else you got is up to date. Number 1, what is unique about surface waves? Number 2, what order do the 3 size waves appear? And 3, what earth layers can P waves and S waves pass through? So go ahead, pause this video, answer this on page 9 of your notebook, and do your very best. See what you guys have. Give you guys a moment. Okay. Moving on to our Go Blue answers. Number 1, surface waves. As you remember, we talked about these the other day, right, with our earthquake stuff. They are the slowest waves, but they do the most damage. Right? Again, their alternate name, we know P waves are known as longitudinal waves. We know that S waves are known as transverse waves. Alternate names of our surface waves are called Love/Rayleigh waves. Love/Rayleigh waves. Let's just go ahead and show number 2. The order of the waves, we've got to know this. You're going to be quizzed on this, okay? P waves are first. They're the fastest, also known as primary waves. S waves are second, hence why they're maybe called secondary waves. And our surface waves are going to be the slowest. Surface waves are last, but like we talked about, they do the most damage. Number 3, okay, P waves pass through all the layers, as we remember discussing in our notes, I think on page 8 or 6. P waves can pass through solids and liquids. Thus, they pass through all of the Earth's layers. But S waves, a little different. They can't pass through liquids. So what's the only layer of the Earth that we wrote down on page 4? That is a liquid. S waves, again, it is going to be outer core. The outer core they cannot pass through because the outer core is a liquid. Okay, keep that in mind. Keep that in mind. Okay, and we can see this little chart down here, right? We see P waves passing through easily, with the S waves being halted and stopped immediately once they get to liquid outer core. Again, S waves, as we saw in maybe some of the Slinky GIF, you can see, again, that S-type movement, it struggles to continue once it gets through the fluid. It gets stopped more easily because of the particles moving around and such. Okay, no need to worry about test makeups. Again, table of contents, guys, on page 1. Pages 9 through 11, we've begun Earth's magnetic field and heat. Going to get into some heat stuff Tuesday as well. So, but magnetic field, or Monday next week, magnetic field is the topic that we are going over. Okay, so let's go ahead, guys. You are now going to go to page, I'm going to say 11. Go to page 11. The title of page 11, okay, should be title of page 11, like we talked about, should be Earth's magnetic field and heat, or magnetic field and convection. Either one is fine. But again, we are now on page 11. 9 and 10 are going to be video questions and Go Blues. Page 11 is going to be our notes for the magnetic field. You're only going to write down what's highlighted. So things I've got like with lines through it, things that are not highlighted, do not worry about. Okay, so go ahead. In the yellow, we have a question on page 9. Our first video question of this section is going to be, why does Earth's magnetic shield matter? Why is the magnetic shield important? Okay, why? So Earth It's a planet, obviously, right? It's a ball of rock and dirt and magma and metal, but it has a force field around it, a magnetic shield. Why is it important? I need you to go and try your best to answer that. I'm going to show you, like I've said before, time and time again, I'm going to show you a little sample of this video, but it's on you to make sure you watch and answer these questions. Let's go ahead and check it out.
For Earth-like planets and find the signature of life there. Requires billions of years and a powerful force field like the one we owe our lives to every day.
There's this magnetic shield, right?
If an alien astronomer were to file a report on our home solar system, they might make a surprising observation. Because of all the 8 planets that orbit the Sun, they could easily conclude that 2, not 1, were suitable for life.
And what you'll find is they talk about Mars versus Earth, because Mars once had a magnetic field. It does not anymore. And you're going to have to watch to find out, well, how did that change Mars and how did it impact Earth, right? So really look at those 2 things. Answer that question, why does our shield matter? What does it do for our planet? And what happened to Mars once it lost its, right? So go ahead, answer that, watch that on your own. Make sure you have that for another notebook check that will be happening in 2 weeks. Let's go ahead and go back to our presentation. Okay, got to answer those questions on your own. Again, watch the video, answer those questions from the video. And we're going to skip through this, guys. We're going to get into conduction, convection, radiation. I do want to define magnetic field. So go ahead and let me just highlight. Did I highlight all this? Yeah, I did. Okay. So just what's on the bottom portion of this slide, I do want you to include, just define what a magnetic field is, okay? Define and have what it is on page 11. Like I said, page 11. A magnetic field, as stated below, is a region around a magnetic material or a moving electric charge within which the force of magnetism acts. So again, Earth is not just a ball of rock and water. It's got metal inside of it, and that metal generates a charge, a magnetic shield, which provides us with a lot of benefits, which we're going to talk about in the Go Blue on our lesson Monday. But you guys need to watch that video to get that information beforehand, okay? So again, that is our definition of magnetic shield. We'll get into more details on what it does for our planet on our next video lesson, okay? Now, really important. I know it's not highlighted because it's an image, but you guys really need this. This is really important. I'd like you guys on page 9 as it states here actually, below the video question you just answered. I just want you to write down these 3 types of heat transfer. I want you next to those write their definitions, and then I want you to doodle and draw these little illustrations next to that. It'll really help you better understand them, okay? So conduction, you've heard these before, but we got to kind of just, again, the state wants us to make sure we cover certain topics year after year. So like I said, it's just a brief kind of recap on these topics you've heard before. Maybe in physical science last year, maybe in biology the year before that, right? Or maybe in chemistry, obviously. So conduction, guys, energy, heat. So heat, right? Heat is just energy. So conduction is how you transfer heat by touch, by direct contact. Thus, we've got a picture of touching like a hot pan, right? So you got a pan sitting on a stove, okay? That's going to be conduction. So anything that involves touch is going to be conduction. Now, convection, what's that? Well, it's not heat transfer through touch per se. It's heat transfer by molecules going to your hand or going to you. A great example, again, the mass motion of molecules. A great example of that we have here is steam. Steam is always going to be convection. Steam is convection, okay? And then lastly, we've got radiation. Radiation is heat transfer by electromagnetic waves. Heat transfer by electromagnetic waves. It's like a fireplace, maybe like a lamp, right? That is radiation. So we're going to get questions on these in our unit quiz. You got to be able to differentiate these. Okay, differentiate which is which and why which is which, right? So go ahead, get that down. Write those, just the top half, guys, just the top half. Each of these heat transfers, define them, and have a little doodle next to those. It'll really help you better understand these, okay? So again, make sure to write these on page 9, page 9. And let's go ahead. I've actually got a fun Bill Nye video to show you guys that ties along with that. He's going to be in a kitchen. And they're going to be cooking pancakes. You need to watch all this on your own. But I'm going to show you a snippet of kind of what he talks about here. Pretty cool stuff.
Ways. So there you go.
Thanks.
Heat moves around the universe in 3 ways. So let's take a look at the part of the universe we call the kitchen. These pancakes are touching this hot griddle. So heat can go directly from the griddle into the liquid pancake batter fast enough to turn the batter into a dry pancake. Here we have fruit cooking over boiling water. The steam cooks the fruit all the way through.
Then steam, what would that be? Think about it. Convection, right? You gotta always love Bill Nye videos. They're just always fun. But do watch that all on your own. I guarantee to help you remember convection, conduction, radiation even better than you did before. So I will post that link. Just 2 minutes, guys. 2 minutes. I will post that link to our update here once I have this video lesson done. Okay, now let's go back. I think that might have been everything we talked about today. Oh, last thing we mentioned, density. Just a quick rehash on density, right? Again, just write the title and what's in yellow, okay? So again, what is density? It's the degree of compactness of a substance, how compact, how put together a substance is, how close together its particles are. Take a look down here. Take a look down here, guys. We've got Diet Coke and Coca-Cola in water. One floats, the other does not. Diet Coke, well, has a lot less sugar, has a lot less starch, corn syrup, things like that. It's going to float, less dense than water. But Coca-Cola, heavier on the sugar, heavier on the starch and the corn syrup. Probably why it goes down and does not float in water. Pretty interesting stuff. And guys, just so you know, this impacts how easily states of matter change. So how easily something goes from a liquid, solid to a gas, and et cetera, right? So if it's less dense, probably allows it to change those states of matter more easily, right? More easily. So good, just that's it for the day, guys. You need to write density, write that down on page 11. That goes on page 11. I do want to provide you guys with a few practice questions. So let's quickly go, let's just do 2 maybe brief practice questions if I can find some. Yeah, why not? Let's try this, okay? So, which seismic wave is the most destructive? We saw this on our Go Blue earlier. Is it A, P wave, B, S wave, or C, surface wave? It's going to be C, surface wave. And our last question of the day, guys. Again, pause the video to go over the questions. Which seismic wave is unable to travel through liquids in the outer core? Got to know this. This is very important. You've seen this time and time again. It's going to be B, S waves, B, secondary waves. Guys, that concludes our lesson for today. Again, get that notebook check done. Get that quiz done once your notebook's up to date. Once I posted it, hopefully tonight, Friday, or by Saturday morning. And again, get those done. Get those lessons up to date. Get that notebook up to date and get your assignments turned in. I'm going to try and scan these workbook pages and these textbook pages for our next assignment as we move forward. But I'm going to go ahead. Guys, if you have any questions, let me know. Mr. Campbell, again, message me on Canvas. Have a great weekend. And Mr. Campbell, signing out.